Hall effect sensors can also provide a voltage signal and, like the inductive type, can be mounted on the crankcase wall or inside the housing of the distributor. The sensor has a permanent magnet and a Hall switch as part of its assembly, and an air gap between the magnet's north and south poles. The switch is on one pole of the magnet, and an interrupter ring with a number of square-shaped blades or segments rotates through the gap formed by the poles. When it's used in a distributor, this interrupter ring has the same number of blades as engine cylinders, and a corresponding number of windows or gaps between the blades. The magnetic field is strongest when the gap is aligned with the poles. This allows the switch to earth a low current signal voltage that is applied to it. When the interrupter ring rotates so that a blade is in line with the poles, the magnetic field is shielded and the signal voltage is not earthed. With continuous rotation, the blades repeatedly move in and out of the air gap, and the signal voltage will appear to turn on and off repeatedly. The control unit uses this on-off signal to detect engine RPM and to control ignition timing. If a sequential injection mode is used, the position of the camshaft must also be signalled to the control unit. This is done by making one blade of the interrupter ring shorter than the others. It's called a signature blade. It passes through the sensor and alters the signal, so that injection commences at the correct time in the cycle. Since the distributor rotates at camshaft speed, the sensor in the distributor provides camshaft position readily. When the sensors are on the crankshaft, a separate sensor is needed for camshaft position. It identifies when to commence injection for the number 1 cylinder. Injection for the other cylinders then occurs in the same sequence as the firing order.